Alright, here we go. Chapter 7. We are getting into polygons. So, we're going to have a couple pages and notes on kind of what polygons are, basic definitions, and then get into the formulas that you need to know. Polygons. And the deal is a polygon is a closed figure made up of a specific number of sides. So no curves. And what closed means is that all lines connect. And an example of something that is not closed would be something like this. Here you have a problem. Hey, that's not closed. A couple other terms are concave and convex. Concave, think like a cave-in. Your shape is going to cave in at some place. Something like that. We got a little cave-in right there. And we have a term called convex. Convex just means shape does not bend in. So something like this. Here you'll notice our shape does not bend inward. It does not bend inward at all. So we call that convex. And another term is the term regular. A regular polygon. What a regular polygon means is all sides are congruent and all angles are congruent. Okay, so this would be like the most common shape would probably be a square. So a square you've got, 490s, and with a square all the sides are congruent as well. But you can also see it for an equilateral triangle. All the sides would be congruent and all the angles would be congruent. You're going to have information, or you're going to have it stated that the polygon is regular. And another guy might be like this. We're just going to pretend all the sides are congruent and all the angles are congruent. So any size of polygon can be a regular polygon. It just means all your sides are congruent, all your angles are congruent. I think you'll see that term a few times this chapter. Now, I do want to spend some time talking about the different names of polygons. For example, right here we said squared, and we know that's a triangle. This guy's a five-sided shape, so we're going to get into some of the names for that five-sided guy. That's actually a pentagon. So, we're going to classify some polygons with names and sides. And of course, we're going to start with triangle. That's got three sides. You can't have a two-sided polygon, otherwise it's not going to be connected, because you got like your two fingers. You can't. I mean, you go like that, but now you have a what's it called? A curve. So you can't make a polygon with 2 sides. It's got to be at least 3 sides. After a triangle, we have a 4-sider. We're going to call that a quadrilateral. Quad means 4. If you guys like, those kind of dirt bike type things, quads, a four-wheel vehicle. Pentagon, that's our 5-sided. Hexagon, 6, and heptagon, 7, 8-side, octagon, 9-side, nonagon, and 10-side decagon. You might see a 12-sider, that'd be a dodecagon. And for the last one, we're gonna write n hyphen gon. So any side length, that could be like a 19 as my n, so that's like a variable. I could put 19 hyphen gon, and the 19 is the number of sides that shape has, okay? So again, lots of terms. Get that down. Next page. More parts. We're going to talk about the different angles formed in a polygon. So polygon angles. If we have like a pentagon, do something like that. You've got 2 types of angles. You got interior angles and exterior angles. We're going to talk about interior angles most today. Interior angles, these are inside. These guys are all interior angles. And interior angles increase as more sides are added. Okay. And your exterior angles, these are a little different. Exterior angles grow smaller, and these are your exterior angles. Your exterior angles have to be drawn such that if they were to extend, they wouldn't cross. Okay? So for example, if this line was to extend and this line was to extend, they wouldn't cross. But if I made my exterior angle the other way, then my lines would cross over here. So those are my exterior angles. And these guys grow smaller. Actually, I should label them for you. Exterior angles grow smaller as more sides are added. Now exterior angles always add up to 360. So if you add up these guys, all my dotted angles, however many sides I have, exterior angles, the sum of exterior angles is always going to be 360. Okay, so the sum of exterior angles is always 360. And one thing that I hope jumps out to you guys is this is a straight line. We have an interior angle and an exterior angle. Hey, look, that's supplementary. Interior angles and exterior angles are supplementary. You will be using that to solve problems. Next piece is a thing called a diagonal. A diagonal pretty much forms a triangle inside of a polygon. And it's a line from one vertex to another vertex. And you can't have them cross if you're finding the angles. So I'll show you kind of how these work. If you had a rectangle, you can draw a diagonal from one vertex to another vertex. Boom. You don't really want to go right next to each other because that doesn't make anything. And you'll notice you got yourself you got two triangles right there. Now remember, excuse me. How many degrees are in a triangle? 180. We've got ourselves two triangles right here. So we can go 180 times 2, and we would get 360. 360 is the number of interior angles inside that quadrilateral. Okay? So what diagonals can be used for? They're used to divide a polygon into triangles so that we can find the sum of the interior angles. And I think some of your IXL questions will ask, like, how many triangles can you make here? We'll do a pentagon also. And with the pentagon, vertex to vertex, vertex to vertex, 1, 2, 3. We have ourselves 3 triangles. 180 times 3 would be 540. Cool. And what about a hexagon? You can draw these any way you want, as long as triangles are made. Is that the only way to split that? No. But you'll notice I have all triangles now, and my diagonals do not cross each other. So I can go 180 times 4 equals 720. So diagonals are a nice visual way to figure out how many degrees are in a what's it called, a polygon, by splitting it into triangles. And one thing, if you notice, you got 4 sides. 180 times 2 gives 360. If you add one more side, you're adding 180. You add one more side, you add another 180. So with every side that you add another triangle that can be formed. Okay? And the relationship between sides and triangles formed, 4 and 2, 5 and 3, 6 and 4, is number of sides minus 2. So there's actually a formula. This is one of the formulas we got to know. It's called the interior angle sum theorem. Okay. And what it is the sum equals 180 times n minus 2, where n is your number of sides. So if you were to be asked, hey, let's do an example real quick. What's the interior angle sum of a 16-gon? Well, you take 16, sum equals 180 times 16 minus 2. That's my number of sides. And then I just solve that guy. So 16 minus 2 is 14. 180 times 14. Oh, I need my calculator for that one. Sum equals 2,520. Boom. Now, what about a heptagon? Well, with the heptagon, we have to remember, how many sides does that have? Hepta. So we can look back in our notes. Hepta is 7. So we go sum equals 180 times 7 minus 2. 180 times 5, and that would be 900. Cool. Done. Now, to kind of go off this formula, you can also work backwards. If you're, like you might be given the sum and told to find the number of sides. So if we want to use this formula and I say, hey, look, your sum is 3,060. How many sides does that shape have? Well, we're going to use that formula and put 3,060 in for the sum, and then do a little bit of algebra. And then we just, classic algebra, we want to isolate our variable, so we're going to get rid of that 180. We got 17. We can just add 2 both sides. Boom, there's my number of sides. Now you can do a decent amount with this formula. I'm trying to think of anything else I need to show you guys. Let's see here. I think that might be about it for today. I guess one last thing we can do, we can find an exterior and interior angle. So if I was to say, hey, for a 30-gon, find the measure of one interior angle. We're going to use our sum formula again. We're going to find the sum first. Sum equals 180 times 30 minus 2. 180 times 28. And we have our sum equal to 5,040, which is a big number. But we're not done. We want to find the measure of one interior angle. So we take our total and divide it by however many sides we have. How many sides do we have? Boom, given in the problem. So we're going to go 5,040 divided by 30, and we get ourselves 168. So that's the measure of one interior angle. And if we wanted to go forward to next lesson, we could actually talk about, hey, well, we could get an exterior angle from that too now. Because remember, interior angles and exterior angles are supplementary. So we could go 180 minus 168, 12. And 12 would be our measure of one exterior angle. Cool. So this section and tomorrow's section is going to have a decent amount of algebra. Not terrible. But again, this is kind of how the formulas are used. I will do a few more examples if you want to check those out. Again, thanks for watching, and check out that examples video next, please.